Let's continue with the next example. On example number 3, we have total of 52 cards. And how many suits do we have? We have 1, 2, 3, and 4. Now, the first suit, this is the spades. Then we have the clubs. You have the diamonds. And we have the hearts. We have a total of, how many colors do we have? We have 26 black. And we also have 26 red. We have 13 diamonds and 13 hearts, so a total of 26 red. Many of the times they're going to be asking you about whether we have face cards or non-face cards. Face cards are basically the jack, the queen, and the king. And why are they called face cards? Correct. Because they have a face on the card. And we have a total of 12. Non-face cards are all the cards that don't have a face. And how many do we have? 40. So you want to be able to be familiar. A lot of the times, just like on this example, they are going to actually spell the information for you. And it says, if the order in which cards are dealt is not important, how many 5-card hands are possible? So how many different ways can you get 5 cards? How many are available? 52. How many can we select at a time? 5. And then we just plug it in. So it'll be 52 factorial over 52 minus 5 will be 47 factorial multiplied by 5 factorial. And I'm going to do the same thing that I did above. I see a 47, so I'm going to stop at 47, 52, 51, 50, 49, 48, and I'm going to write down, for the rest of them, I'm going to write down 47 factorial. Because the 47 will cancel with a 47 factorial. But let's not forget the 5 factorial. It will be 5 times 4 times 3 times 2 times 1. Now we can cancel. Let's see, what can we cancel? We have 5 and 2 will give me 10. And I'm going to divide this by 10, will give me 5 on top. 3 times 4 is 12. And I can reduce it by the 48. Divided by 12 gives me 4. So this will be 52 multiplied by 51 multiplied by 5 by 49 and by 4. For this case, I'm just going to use my calculator to multiply it out just because it's such a huge number. On your homework, you will have smaller numbers. 52 times 51 times 5 times 49 times 4. And that'll give me equal to 2598960. So there are 2,598,960 ways that you can get 5 different cards. Remember, the order does not matter. Now let's continue with example B. How many different 5-card hands with all hearts are possible? So we're looking for, in this case, we're also looking for 5 cards, but we want them to be all hearts. So let's not think about the all 52 cards. The only ones that we are looking for are hearts. So how many different hearts do I have available? 13. How many am I going to select at a time? Will be 5. So it'll be 13 factorial over 13 minus 5 will be 8 factorial multiplied by 5 factorial. That'll give me 13 times 12 times 11 times 10 times 9, and the rest of it will be 8 factorial. Because that will cancel with this 8 factorial. And then I still have my 5 times 4 times 3 times 2 times 1. 5 and 2 will be 10. 3 and 12, 4 and 3 will be 12. So in this case, we just have 13 times 11 times 9. That'll be 13 times 99. And I'm going to multiply 99 times 13. That'll be 27. Carry 2, 27, 2, 29. And then it'll be 7, 18, and 13. Plus a 2. That'll be 1,287 ways. Now let's continue with the next example. We'll go and pause and see if we can do letter C and letter D. Pause it and then we'll work it out together. Ready? So in this case, it's asking how many 3-card hands are possible that are all red. We have, how many red ones do we have? We are only looking for the ones that are red, so we don't care about all the spades and all the clubs. How many red ones do we have available? 26. How many are we selecting at a time? 3. That'll be 26 factorial over 26 minus 3 will be 23 factorial multiplied by 3 factorial. Max expand 26 times 25 times 24 times 23. I'm going to stop right here because that will cancel with a 23 factorial. If you want to write it down all the way down, that's fine. I like to make my life easy. 2 times 1. Now I'm going to cancel 3 times 2 is 6 and reduce it with a 24. That gives me 4. So it'll be 26 times 25 times 4. That'll give me 100 multiplied by 26, and so it'll be 2600. There's 2,600 ways. There are 2,600 ways that you can select 3 cards that are all red. And the last one. If the order in which the cards dealt are not important, find the number of possible ways that you can get 5 card hands that contain no face cards. Remember, we only concentrate on the ones that have no face. We have, how many non-face cards do we have? 40. And how many do we want to select at a time? 5. That'll be 40 factorial over 40 minus 5 will be 35 factorial multiplied by 5 factorial. I'll go through the same process. 36 and 35 factorial. That 35 factorial will cancel out. And I still have my 5 times 4 times 3 times 2 times 1. See, 5 times 4 is 20 and 2 is 40. I can reduce my 3 and my 36. That'll give me 13. Therefore, I'm going to have 39 times 38 times 37 times 13. And once I multiply it together, that'll give me 658,008 ways. Okay, let's continue to the back. On the back side, we are going to be dealing with multiple events. When we are finding the number of both events, event A and event B to occur, we're going to calculate the number of ways to select A and then the number of ways to select B, and then we're going to multiply if it's an AND. Now, if it's an OR, we want the number of ways that an event A or event B can occur. We are basically going to calculate them separately and we're going to add them. For example, example number 4. You are taking a vacation. You can visit as many as 5 different cities and 7 different attractions. So there are 5 different cities available to visit and 7 different attractions. Suppose you want to visit exactly 3 different cities and 4 different attractions. How many different trips are possible? It's like if you go into a travel agency and the travel agency goes to 5 different cities and 7 different attractions, and you buy a packet that will allow you to visit 3 cities and 4 attractions. How many different ways you can select your trip? The keyword is and. Now, how many different trips are possible for the cities? How many are available? 5. How many can we select from? Or how many are we selecting? 3. It's an and, so we're going to multiply it out. Now for the attractions, how many different attractions are possible? 7. How many are we selecting? 4. So let's go and expand it. We have 5 factorial for the first one, and then 5 minus 3 will be 2 factorial, multiplied by 3 factorial, times 7 factorial for the second one, and 7 minus 4 will be 3 factorial, multiplied by 4 factorial. I'm going to go expand it. 5 times 4 times 3 times 2 times 1. Denominator will be 2 times 1, and then 3 times 2 times 1. Multiply 7 times 6 times 5 times 4 times 3 times 2 times 1. Denominator will be 3 factorial will be 3 times 2 times 1. 4 factorial will be 4 times 3 times 2 times 1. So the 3 cancel, the 2's cancel, the 1 cancel. The 4's cancel, the 3 cancel, the 2 cancel, the 1 cancel. We don't need the 1 on the bottom. 3 times 2 is 6, that cancels. I can reduce the 2 and the 4, divide by 2, gives me 2, gives me 1. So what do I have left? 5 times 2 on the first one, and then 7 on the second one. 7 times 5. That'll give me 10, that gives me 35. So for the first one, how many different ways can you select? 5 cities, that's 10. How many different ways can you select 3 cities? That's 10. How many different ways can you select 4 attractions? That's 35. Because there's an and in between, we're going to multiply, and we have 10 times 35 will be 350 ways that you can plan your trip.